You are tuned to IRI Learning, and I am your host, Teacher Teacher. In this lesson on mixtures and separation, we will look at the separation technique, fractional distillation. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to determine the properties that allow for the separation of the components of a mixture by fractional distillation and explain the process of fractional distillation. Let us do a quick recap. Remember that the components of a mixture are separated based on their physical properties, which include particle size, crystalline shape, boiling point, solubility, magnetism, sublimation, density, and other properties not noted on this particular list. So what is fractional distillation? Fractional distillation is used to separate a mixture of different liquids. But what is most important is that these liquids must have different boiling points. Next, we will examine the apparatus setup and give a description of the procedure for fractional distillation. Here is the apparatus we use for fractional distillation. At first glance, you may notice that the setup is similar to that of simple distillation, but there's one key difference, which we will discuss shortly as we examine each apparatus in the setup. So first, we're going to start with the wire gauze and the tripod. And as we learned previously, the wire gauze is a metal mesh that sits on top of the tripod, providing a surface for the reaction flask or the round bottom flask to sit on. And the tripod stand gives support and a space for the heat source to get under the experiment flask. Next, we have the round bottom flask, also known as an RB flask, RB representing round bottom. And this is the container in which the liquid mixture is placed. So in the RB flask, we have a mixture of 2 or more different liquids, and it is important that the liquids have different boiling points for this technique to work. It is always good to add a few granules of boiling chips, also known as anti-bumping granules, and this is there to prevent the rapid or furious bumping or popping of the solution while boiling. Connected to the RB flask is a long column containing lots of glass beads, and this is called the fractionating column. If you watched the video on simple distillation, you would have noticed that a fractionating column was not used in that technique. And if you want to review the video on simple distillation, just take a look in the description box for the link. Now, the glass beads or rods inside of the fractionating column actually help to separate the liquids according to their boiling points consecutively. That is, the vapor of the liquid with the lowest boiling point will pass through the fractionating column first, while the vapors of the liquid with the higher boiling points will cool and return to the mixture in the RB flask. At the top of the fractionating column, we have the thermometer, and the thermometer records the temperature at which each liquid in the mixture comes off as a vapor. The temperature remains at a fixed boiling point for each liquid as it evaporates, and the temperature indicates which liquid in the mixture is coming off. So you can have a fair idea when you notice that the temperature is changing, you know that it's time to change the collection flask as the next fraction will be coming off. The fractionating column connects to a condenser. Remember, there is circulating cold water surrounding the inner tube of the condenser, and as the vapor passes through the condenser, it is cooled and changed back to a liquid. And the liquid that is collected is called the distillate or fraction. So the fractions refer to the separate liquids collected from the mixture. So let's see how fractional distillation works. Imagine we had a mixture of ethanol and water in our round bottom flask. We know ethanol has a boiling point of 78 degrees Celsius and water has a boiling point of 100 degrees Celsius. So both liquids in the mixture will have different boiling points. We start by gently heating the mixture. Both liquids will start to evaporate, but the one with the lower boiling point will evaporate more easily. As a result, we have a mixture of 2 different vapors making their way into the fractionating column. When the vapors hit the fractionating column, the vapor of the liquid with the higher boiling point will cool, liquefy, and return to the mixture in the RB flask. This allows for the vapor of the liquid with the lower boiling point, and in our imaginary experiment, that's ethanol. And so the ethanol will make its way up the fractionating column ahead of the vapors of the water. And of course, water is a liquid with a higher boiling point. So the vapor of the ethanol passes through the fractionating column and enters into the condenser where it is cooled and changed back into a liquid. So the first fraction or distillate collected would be the ethanol. In other words, the liquid with the lower boiling point. Note that the vapor of each liquid will pass through the fractionating column on reaching its boiling point. So this simply means that at 78 degrees Celsius, the ethanol vapors will pass through the fractionating column and get into the condenser. The temperature will remain constant as long as ethanol vapors are passing through. After the first fraction or liquid is boiled off and collected, the temperature of the thermometer begins to rise as the vapor of the next liquid, that is the one with the next highest boiling point, begins to pass through the fractionating column. So at this point, it is important that we change the collection container to collect the next liquid fraction. So we basically now have separated the two liquids based on their boiling points. Note, if the boiling points of the liquids in the mixture are very similar, then multiple rounds of fractional distillation would be necessary to obtain pure samples of each fraction, that is the liquid collected. Uses of fractional distillation. Fractional distillation can be used in the purification of water, separating water from acetone. We can also separate the components of crude oil, which is commonly used in oil refinery. Like, for example, crude oil contains a mixture of gasoline, diesel fuel, kerosene, jet fuel, and others. But note that the fractional distillation at the industrial level is quite different from what we will do on a small scale in a school laboratory. Fractional distillation is also involved in the purification of organic solvents and products. So it's time for our lesson summary. First, fractional distillation is used to separate a mixture consisting of two or more different liquids, with each liquid having a different boiling point. Secondly, fractional distillation uses a fractionating column, which is the apparatus that makes it quite different from the simple distillation process. Third, we have the vapor of the liquid with the lower boiling point passing through the fractionating column first. And finally, the distillate of the different liquids collected are called fractions. Are you ready, learners? It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Which statement best defines fractional distillation? A. The process of separating the different liquids of a mixture based on their different densities. B. The process of separating the different solutes of a mixture based on their different boiling points. C. The process of separating the different liquids of a mixture based on their different boiling points. D. The process of separating the different solutes of a mixture based on their different densities. The answer is C. Fractional distillation is the process of separating the different liquids of a mixture based on their different boiling points. Question 2. All the following are uses of fractional distillation except A. Purifying organic solvents. B. Separating the components of crude oil. C. Separating the components of an alloy. D. Separating water from acetone. The answer is C. Separating the components of an alloy. An alloy is a mixture of different metals. Question 3. What term is used to describe the different liquid distillates collected during fractional distillation? A. Solution. B. Mixture. C. Vapor. D. Fractions. The answer is D. Fractions. Question 4. Which apparatus is used in fractional distillation but not in simple distillation? A. Condenser. B. Fractionating column. C. Thermometer. D. RB flask. The answer is B, fractionating column. Question 5. Identify the statement that best describes the function of the fractionating column. A, the fractionating column aids in the separation of the vapors of the liquid mixture according to boiling point. B, the fractionating column only allows the vapor of the liquid with the highest boiling point to pass through to the condenser. C, the fractionating column removes impurities from the vapors. D, the fractionating column liquefies the vapors to give the pure fractions. The answer is A. The fractionating column aids in the separation of the vapors of the liquid mixture according to boiling point. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with iRe Learning.